Hi, and welcome to section 2.7, Measures of Spread of the Data. We're going to be talking today about standard deviation and variance and how they are used to measure how far apart the data is. We're going to start with an example. Here's a list of all the close friends of Jasmine. The mean of their ages is 41.5, but you can see no one is exactly 41.5. They're either older or younger than the average. So what we're going to do is we're going to calculate deviation and get to give us a feel for how spread out the data is. So we're going to walk through this calculation here. You will not be asked to do this by hand on a quiz or test. We're going to be using Excel to calculate this from here on, but I did want you to see how the calculation worked once. So hang in there and just follow along. So as we remember, the average age is 41.5. So what we're going to calculate first is how far each individual age in the data set is away from the average age. So for example, if the average age is 41.5, 41 is a half year smaller than it, right? 38 is 3.5 years less than it. 47 is 5.5 years over it, etc. So what we did is we calculated the deviation from the mean for each of the data points. The problem is the sum of this is always going to be zero. Let you sit down and think about that one on your own, why that's always going to be true. But it is always going to be true. And that's not very helpful. Once we add these guys up, we always just get zero. So we need to do something else. So what we're going to do is we're going to say, fine, okay, we're going to look at all the deviations, how far they are from the mean. We'll square each one. That way, if it's below or above, it'll still count the same amount. Maybe it's a half year below or half year above. It's still a half year away. So we square all the deviations, making all those numbers positive, and we add those up, and that number is called the variance. And in this example, it's equal to 88.5. So here's our sigma notation. What I did was each data point minus the mean squared and add them all up, we get 88.5. To make it an average, we're going to divide by the total number of values in the data set. There was 10, so the average is 8.85. All right? So the variance is 8.85. So unfortunately, 8.85 has the units squared years, right? Square ages, because we subtracted the ages and then we squared them. This makes it hard to sort of interpret in a real life problem. So what we're going to do now to make those units a little bit better is we're going to take the square root of that value. That way our units are just ages. And this new statistic is called the standard deviation. So the standard deviation is the square root of the variance. So here was my variance, 8.85, and here is my standard deviation, 2.97. All right? So when you calculate these from a sample, we actually are not going to divide by the total number of values like we did in this example. We divided by, because this was her entire list of friends, we divided by all 10 friends. When we actually calculate the sample standard deviation, we're going to calculate by one less from the number of items. So to summarize, it's going to be used S squared for sample variance, and we'll use the command just VAR in Excel, and a capital S for, and we're going to use the capital S, the square root of S squared, for standard deviation. And in Excel, we're going to use the command standard deviation. And most of the time, we're going to be talking about the sample standard deviation and the sample variance. For the entire population, like if we know every single data value for the entire population, we would divide by n as we did in our example. We use the symbol sigma squared for the variance, and in Excel we would use the command variance PA, that stands for population, VARPA. And for the standard deviation, we use the symbol sigma, and in Excel we use standard deviation with the PA at the end. Again, most of the time we're going to be using just the sample standard deviation and variance. Why do we do this? Well, the answer to that question is really beyond the scope of this class. If you want to find out more about this, you need to just keep taking more statistics. It would take me a really long time to explain here why we do this, but for now, I ask you to just trust me that n-1 gives us a better estimate of the population variance. All right, we've done a lot of complicated calculations. I've talked about sample and population variances and standard deviations. Let's go ahead and go to Excel and just practice using these. Sure. All right, so let's go to the MyOpenMath page and go down to today's notes. 2.7, please, here is Excel you're going to need. So download your Excel file. Open it up. And And let's enable editing. All right, so here is an example of Jasmine's friends, and we're going to calculate we're going to calculate the population standard deviation and the population variance first. Okay, so we're going to do these right here. So we're going to go equals standard deviation. I don't know why I did standard deviation first, but that's okay. PA for the whole population. You select all the values, and then you close your parentheses. Enter. There's our population standard deviation. To find the population variance, you type equals VARPA, and again, select all your data, in your parentheses, and there is our population variance. Maybe I can make this a little bit bigger. All right, now let's suppose Jasmine has 10,000 friends, and we just did a 10-person sample of her friends. And these are a sample. These are data values from a sample. So let's calculate the sample standard deviation. For that one, you just type equals STDEV, just standard deviation. Implies sample. Select the data, end your parentheses. Same for sample variance, equals VAR, left parentheses, select the data, right parentheses. Sample variance and sample standard deviation. All right, so that's how you calculate those in Excel. They're pretty straightforward commands. Let's go back to our PowerPoint here. So in the next example, what we're going to do is we're going to calculate a sample mean, standard deviation, 5-number summary, range, interquartile range. We're going to construct a box plot and construct a histogram. This example is going to be very, very similar to what you're going to be doing in your write-up. And in fact, the results of this example you're going to be used for a comparison in your write-up number one. So write-up number one is going to be asking you to do all these things with a very similar data set and compare it to the work that I'm doing here. So let's go back to our Excel file. It's already in there. It's called Simplified Data for Lecture. And let's make this a little bit bigger. So this data is based on a sample or an experiment that I got off a website. I think what the website's called Zazzle or something like that. And what this experiment did was it gave people a drug or a placebo, and then before giving the drug, they were given a memory score, and after the drug, they were given a memory score, and it computed the difference in those scores to see if the drug had an effect on their memory ability. I've simplified the data a little bit for our class because it had a lot of different variables in it. But in this one, the variable is just going to be the difference in our memory score. The population is every person who takes the drug, every human being, as I guess would be our population. And the sample in this case is the people who are given S, which is the drug that is a placebo. When you guys do this in your write-up one, you're going to be doing drug, I think it was drug A, which turned out to be Xanax. All right, and you'll see that there is how many people in the study. Well, it starts at number 6 and it goes until number 71 inclusive. So I think that makes 65 people in this study. And so let's go ahead and calculate all these different statistics now that we know how to do all these together. I can't seem to get this in a good window. Here we go. A bit more. All right, so what we're going to do is we want to know the sample mean and their difference in memory score. So that's going to be equal to average of all these values. And it goes from F6 to F71. In my parentheses and hit enter. So the average is negative 0.17. Let's look at the sample standard deviation. I want a few less decimals. That looks a little busy to me. There we go. The sample standard deviation, we just learned about that. That's equal to STDEV, left parenthesis. And it was here to here, F6 to F71. I might start typing that in because this is getting kind of tiresome. And the standard deviation, I'm actually going to decrease the number of decimals on that one too, is 7.5. All right, how do we find the minimum? Equals min, and it was F6 to F71. The minimum value was negative 40.4, biggest memory difference, I guess. The first quartile equals quartile F6 through F71, comma, first quartile. Median third quartile. Oops, I did need to type an F over and over again. All right, our max is 16. That means they improved 16. And the interquartile range, well, this is going to be equal to the value we have in Q3 minus the value we have in Q1. Now, you could just compute 3.4 minus negative 2.8. That's fine. But I just actually referred to the values in those cells as an Excel, a little bit more of an Excel tip. So I put equals the value in this cell minus the value in that cell. And the interquartile range is 6.2. All right, so that's how you go about computing all those statistics. Hopefully you remember how to do a histogram and how to do a box and whisker plot. I'm not going to do those right now. All right, let's talk about comparing standard deviations. Let's look at the chart below. This is going to be some data from, I made this up. This is data from sales of 3 different stores located in Portland, Detroit, and Baltimore. Their stores of the same size, and it reports their mean sales per day and their standard deviation. When you look at the data, you can see that their mean sales per day are about the same, but the standard deviations are very different. What does that tell us? Well, the larger your standard deviation, the larger your data is from the average value. So each day, they're going to have a larger variability in sales if you have a larger standard deviation. If your standard deviation is smaller, that means that distance from the mean to each data value is smaller, and you're going to have less deviation or less range of values for the data. So if we look at this data, that means that the sales in Portland are way more variable per day than the sales in Detroit. So Portland might have $2,000 one day and $10,000 the next, and zero, and really wide values. Where Detroit is going to have values pretty similar every single day, and Baltimore is in between those two. Let's look at another example. Just looking at these two data sets, don't use Excel, don't use your computer, just look at them. And which one do you think is going to have the bigger standard deviation? Take a moment, pause the video, and see if you can figure it out. All right, which one do you think had a wider range of values? The top one. The top one has a bunch of ones, a couple fives, and nines. Both of these have a mean of 5. That gives you a standard deviation of 3.77. These guys are all really close to the mean of 5. It only has a standard deviation of 0.94. So again, remember, bigger standard deviation, bigger range of values of your data. Smaller standard deviation, smaller range of values of your data, and your data is going to sit closer to that mean. That's all for section 2.7.